Okay, Algebra 2 kids, we're kind of in the middle of long and synthetic division right now. And I'm not there to do whiteboards with you today because I have meetings today. But I am going to give you some extra practice to work on long and synthetic division. So you need to get this from my sub. The one side is long division and the other side is synthetic division. So as soon as you have that, the first thing that I want you to do is actually circle the part where it says long division and then circle on the other side where it says synthetic division so you know which side is which. Okay, we are going to do the top one on each page together just so you can get an idea of what you're doing, and then you'll do the other three for homework. Okay, so I'm going to start on the long division side, just in this box you have set up where you can show your work, and then you're going to actually write your solution over here, and then we'll talk about what this check remainder is, because we did not do that before, and so I'll show you what I want you to do in that box. But let's go ahead and get our first problem set up, and we will get rolling on this one. I told you before that you have to be careful when you're doing these problems because you want to make sure that you have all of your spaces filled and you don't have to put like a 0 in anywhere. So here we have x to the third, we have x squared, we have x, and then we have our number here. Okay, so we don't have to put 0 in any placeholder there. But if you look at like the second one, we have an x to the fifth, we don't have an x to the fourth. So go ahead and real quick and put plus 0x to the fourth in there, because when you go to do this long division, you will have to put a 0 in the placeholder for that one. Okay, x to the third, what just happened? X to the third, x squared, x, and number. So everything else is there, but we will need to put a 0 in there for the x to the fourth. So maybe go through and check those at some point to see if you need to put any placeholders in there. Okay, the first one doesn't, so let's just get to work. We have, let's see, x, I'm going to put this all the way at the top. X minus 3 goes on the outside, and we are dividing that into 2x to the third minus 5x squared plus x minus 8. This is what we're dividing by. Okay, so the first thing that we do is say, what do you multiply by x to get 2x to the third? He needs a 2 and an x squared. Okay, then we multiply them back through. So 2x squared times x is 2x to the third. And now we finally look at this minus 3 for the first time. We don't do anything with the minus 3 until we multiply it back through. So 2x squared, this guy, times the minus 3, ends up giving us minus 6x squared. Okay, then this is the most important part I told you. We have to flip the sign, so this becomes minus and this becomes plus. And then these two cancel. We have negative 5 plus 6 is 1x squared. And then we have to bring our plus x down, and we're going to start the process over again. So we say, what do we take times x to get 1x squared? He needs a 1x, or just x. If you want to just put x, you don't have to have the 1. Multiplying back through. So x times x is x squared. X times negative 3 is negative 3x. Then I flip the signs again. So this becomes minus, this becomes plus. And I cancel. And then we say positive x plus 3x is 4x, and then I drop my 8 down, so minus 8. Okay, and then I do this step again. So I'm on my last time. What do you take times x to get 4x? We need a positive 4, and then 4 times x is 4x, and 4 times negative 3 is negative 12. Okay, then I flip my signs again. So negative and positive, these two cancel, and negative 8 plus 12 is a positive 4. Okay, and that's what my remainder is going to be. So I do plus 4 over, I was dividing by x minus 3, so x minus 3 goes there, and that's what my solution is. So I'm going to recopy him over there and make him really nice. 2x squared plus, I'm not going to put this 1 in here, I'm just going to call it x, plus 4 plus, and this is my remainder part, 4 over x minus 3. Okay, there is this guy. Okay, now, wouldn't it be really nice if I had a way of like checking to see if I got the right answer? You know, maybe some of you guys don't care to see if you got the right answer, but like I know for me, like I want to know, like, am I way off? Like I got a remainder. Was I supposed to get a remainder? Was my remainder even right? Like, is there a way I can check to see? Well, there kind of is a way to check and see if your remainder at least is correct. And the chances are, if your remainder, if I got this number right, chances are that the rest of it was done correctly, unless I made 2 mistakes at one point. But chances are, if this number is in the right spot or is the right number, I did all the rest of it to begin with right. Okay, so what we can do to check our remainder, at least to figure out if that's the right number, is let me go back to the original problem. And we were taking this guy and we were dividing by x minus 3. Okay, so what I want to do first is I want to say x minus 3, what I'm dividing by, is equal to 0. And if I add the 3 over, I get x equals 3. Okay, I'm going to circle that because 3 is an important number. Okay, x minus 3 was like what I was dividing by, but that means like 3 is the answer. We do that quite a bit, like when we're factoring down. If x minus 3 is set equal to 0, then x equals 3. You know, like it flips the sign all the time. Okay, well, what we can do to check to see if our remainder is correct is I take this 3 and I'm going to plug it in for every x that I have and see what I get. Okay, so if I take 3 and I plug in 2 times 3 to the third power minus 5 times 3 squared plus 3 and then minus 8. Okay, I'm plugging 3 in because it came from there. All right, now if I do that, 3 to the third power is 27. 27 times 2 is 54. I'm doing some of this, trying to do some of this in my head. 3 squared is 9, and 9 times 5 is 45. Then I have plus 3 minus 8, okay? If I put these two together, 54 minus 45 is 9. 9 plus 3 is 12. 12 minus 8 is, oh, look at that, 4. And it is 4 because the remainder that I got is 4, okay? So that's just a really quick way of checking a remainder and seeing if your remainder is right. I take this guy, set him equal to 0, and then I plug that number in for all of the x's here. The number that you get should always, always match what your remainder is, okay? So remainder, check my remainder, 4, and I checked it. He's good to go, okay? My remainder was 4, all right? So that's what I want you to do is in this box, you can write, like if you don't want to plug him in over here, you can put all this work. I don't know, you can put this stuff over here if you want to instead. In that box, if you need some room to write over there. But anyway, I've checked. 4 is what I should have gotten as my remainder, and I did. Okay, if you end up getting another number, you might want to check your long division because I'm guessing you maybe made a mistake somewhere in here, but you can check to see if you got the answer or at least the remainder is right. Okay. All right, so be careful of that and do those things. Let's do a synthetic division problem, and then I'll let you go. Synthetic division. This guy is what we're dividing by, and x cubed plus 0x squared. We need to put a placeholder in for my 0x squared, okay? Minus 6, okay? We're dividing by x minus 3. Here is my work. Synthetic division goes the opposite direction, and my numbers, like these guys, all go in the top row here. So I have 1, I have 0, I have -7, and -6. That's where my numbers are going to go, okay? Now, in synthetic division, I have to set this guy equal to 0, add the 3 over, x equals 3, so 3 is the number that's going on the outside, okay? I have to do that in synthetic division before I divide. I changed like my number outside of here. It's not going to be -3. It's going to be +3. And when I do that, by changing the sign here, it kind of like flips your sign like you do in long division. So here, instead of, you know, like adding those, I have to flip my sign like I do. And I have to flip my sign, and I have to flip my sign every single time when I write it down. By doing the sign flip out here to begin with, I don't have to flip my sign every single time. I did it once and I'm done, right? Okay, so let's do our synthetic division and then we'll check our remainder and see what we get. Okay, so I'm going to drop the 1 down. 1 goes here. Then I multiply the 3 and the 1 together. And that makes 3, and that goes in that spot. Then I add these two guys, and that is 3. 3 times 3 is 9, and that goes here. Then I add these two guys, -7 and 9 is 2. Then I multiply the 3 and the 2 together, which makes 6, and I add these two together and I get 0. So I have no remainder, all right? When I go back to my original, what I was dividing, I was taking x to the third and I was dividing by x, okay? X to the third divided by x, so that means this guy should be an x squared. This middle one should be an x, and then this should be just a number, all right? So for my solution, I have 1x squared, or just x squared. I have plus 3x, and then plus 2. And I'm not going to put my remainder in there because he used 0. So that's what I get for a solution. All right, we want to go back through and we want to check our remainder. So we do it just the same way as what we did before. And this time, actually, I've already set my x minus 3 equal to 0. So I'm going to plug 3, and I'm going to plug it in for all of the x's that I have, all right? So 3 to the third power. I don't really have to put in the plus 0x squared, you know, because anything times 0 is going to make it go away. But I do have to have it for a placeholder over here when I do my division. Otherwise, it won't end up working out. But when I'm plugging in, I don't have to include that 0 in there, all right? So minus 7 times 3, and then minus 6, okay? All right, 3 to the third power is 27, minus 7 times 3 is 21, minus 6, okay? 27 minus 21 is 6, and 6 minus 6 is 0. So by doing the check remainder thing, I have checked 0. Whoop, 0 should have been my remainder, and it is. So I've checked my remainder, and I made sure. That's something called the remainder theorem. You don't have to write this down. Remainder theorem. And the remainder theorem is the law or the rule in math that says that your remainder should always end up being what you get when you plug that number in. Okay, that's just how it always works out. Okay, so that's something called the remainder theorem, where you go and check the remainder like that. Okay, so go through and do that. Fill out all of the boxes here. You just have 3 problems for long division, 3 problems for synthetic division, and that's all I'm going to give you for today.